This is Professor Dare of Science. This video shows how to investigate linear regression using Microsoft Excel. The first two columns, labeled X and Y, is where in the blue cells you'll enter your data as a set of ordered pairs, X and Y ordered pairs that correspond to points on a graph with a horizontal x-axis and a vertical y-axis. If you need more than in the blue cell area, more than 25 actual data values, you'll need to extend the formulas appropriately, and also the scatter plot backing data would need to be extended. In academic problems, in learning, there's frequently smaller numbers of ordered pairs. And again, if you wanted to stop it right here at this row, row 10, you would either need to change these last range values to A10 and B10. You could do that. Or you could take everything below that's in this sample data that start out and select it, and then hit the delete key to make it all empty cells. Empty cells in Microsoft Excel are ignored by the scatter plot and interpreted as 0, values for formulas. And these formulas, none of them is impacted by these blank cells. Starting at the top, well, before we start at the top, as soon as you enter the data here, this scatter plot will update. If you change any value in it, it will update. It's tied to this data dynamically. It will show you the points that correspond to the ordered pairs as a dot for each point. And the best fit line there, which is the least squared regression line, is also shown along with the equation for that best fit line. Up at the top, the correlation coefficient uses the CORREL function. This value is very close to 1, indicating a strong positive linear relationship in these ordered pairs. The slope of the line uses the slope function, and the y-intercept of the line uses the intercept function. Those are called B for the slope and A for the intercept in statistics terminology. The forecast or prediction line is shown down here, y hat. Normally it's a little hat symbol over the y. In text, y hat is A plus bx, A and B being these values. And if we look at any value that's within the range of x's, we can get a predicted or forecast value. I put 2.3 here because it's in the x data, and you see you get 62.39 approximately. That's bigger than the 57. Keep in mind that the best fit line doesn't go exactly through every single point because they're not all on one line. It's why it's called the best fit or least squares line. You should restrict your x values to the range of values. These ordered pairs are sorted. They don't have to be sorted. The x's could appear in any order, but you can see from 1.8 to 4.63 is the only range of x values that we have an indication that there is a linear relationship. Going out beyond those endpoints, there may not be, for whatever the real world phenomena is behind this data, it may not be linear when you go out there. Outside the endpoints would be called extrapolating, and predicting something within the endpoints is called interpolating. Over here on the right are some comments to remind us that X is called the explanatory variable or the independent variable, and Y is the response or dependent variable. The slope B is also referred to as the marginal change because it's the change in Y per unit change in X. The slope is marginal change. X bar and Y bar, those are the means of the X's and the means of the Y's. So the ordered pair X bar, Y bar, turns out, is always exactly on the least squares line. Those values are calculated here in the spreadsheet using the average function, which calculates the mean. So that point there we know is on the regression line. The coefficient of determination happens to be R squared, the correlation coefficient squared. That's calculated here as well, simply by squaring R. And then the explanation behind it. For a linear model, explained variation is what this coefficient of determination indicates. So 95.78% is explained variation by the linear model. And the remaining, in this case, 4.22%, which is 1 minus the 95.78%, that is unexplained variation due to chance or lurking variables.